Hello, everyone. Thank you for joining us again. My name is Michael Weir. I'm a technical marketing engineer here at Ingram Micro, part of our Cybersecurity Center of Excellence and a CMMC I am here today to talk to you about blockchain for identity and access management. This is what we're going to go through today. First, we're going to talk about a little bit of definitions. We're going to talk about the nitty-gritty of blockchain and IAM, and we're going to make a few conclusions at the end. So first, we need some definitions. Now, first, let's talk about what blockchain is. Blockchain, and this is also a very under definition. There's a lot more complexity to it than this. There's a lot of different ways it can be used and implemented. I always mention people in the comments say you're going to complain. You never do, but still, this is somewhat of an oversimplification, but it's just a list of the things in it that pertain to what we're going to be talking about today in using blockchain for IAM. Blockchain is basically a complicated math equation that there's multiple devices across the world working on simultaneously, meaning it's decentralized, that the community is effectively controlling the computation. In most blockchains, maybe all, once again we can debate that in the comments, all previous records are included in each new record. So that means each new block that's put into the chain is more complicated to deal with than the previous block in the chain, as all the other new ones are contained into it. And then the storage and the storage of the blocks and recording of the results is spread out peer-to-peer style. Now, the reason people like the blockchain is it's immutable, right? Because each new record includes all of the previous records. And it's theoretically secure and tamper-proof because of the fact it's distributed all over the place. Identity and access management. Now, this is very simply defined as getting the right people or right things the right access at the right time. We're usually speaking digitally when we're talking about identity and access management here. It's dynamic and it's layered as opposed to old school single sign-on, which would just be you're authenticated once and you're in. It's part of the whole concept of zero trust and that kind of thing. And a big part of identity and access management is that it is integrated with other systems. It'll, you have multiple apps in there, multiple sources of intelligence guiding people around. It's generally an intelligent access solution as opposed to the old school like plus minus thumbs up thumbs down access solution. So how about blockchain in identity and access management? Obviously, this is something that sounds appealing to a lot of people because identity and access management want to secure identities. What could be more secure than taking an identity and putting it into a block in a blockchain? Because there we go, now our identity is immutable. But there are upsides and downsides to it. So upsides, of course, is like what I just mentioned. It's secure. You've got close control over who can see what. It's immutable. It's nearly impossible to tamper with. Once a block is a block, it's a block, and it's distributed. There's no single point of custody, which means it's very failure tolerant. There's going to be stuff you can fall back on because it is distributed. The downside, of course, is the security aspect of the blockchain is the security of the identity that is in the blockchain. It's not the security of the access to the identity in the blockchain. There's still going to be an app in the middle brokering the identity from the block to the app or whatever else it is you're authenticating into. And then that still becomes the fault, the security weak point is whatever's doing that brokering. There's not really apps out there today that read straight from the block for their own access. There's going to be an identity broker in between. The immutability can also be a downside because there's this thing called attribute drift. Attribute drift is when you're putting things into people's identity that are likely to change relatively frequently. So I'm probably not going to change my name. That's probably pretty safe. However, my phone number might change. My address might change. I might get a new email address. These are all things that when they change cause attribute drift. That block that was made gradually becomes less and less accurate. So either you're going to have an inaccurate identity on somebody or you're going to have to make an entirely new block because that previous block was immutable. And when you make a new block, you're computing all the blocks before it, et cetera, et cetera. We talked about the computational power involved in here. And then it distributed. This one's a little more complicated, but a downside to having this distributed system blockchain is there's something called a 51% attack. A 51% attack is when a single entity gains control of over half of the blockchain's resources and compute and the equations and that kind of thing. Because they control over half, technically they can introduce changes because they're the majority shareholder of it. Part of the security is the idea that nobody is the majority. Now, this is something that mostly would be in the realm of, say, nation states and things along those lines, because it does take a large amount of processing power to do, unless your blockchain is new and immature, in which case there's not a lot of computational power needed. It's relatively easy and foreseeable. Someone might be able to get 51% control over it, and if you don't want your identities tampered with, you're extremely sensitive, something like that, then this 51% attack could be very troublesome to you. It's a consideration you might really want to have. Then, obviously this has ideal uses and non-ideal uses. So the ideal uses for blockchain and I, because I'm not going to say it's totally bad. You might say, oh, you just said all those downsides. Why would you tell anybody to implement it? There are some ideal uses for it. So if you have something that has identities that rarely, if ever, change, that's a good use for blockchain and IAM. So if you're doing a certificate-based management or device identity-based management for IoT or OT, the identity of that device presumably is never going to change, or even if it does change, it'll just be little things like a firmware update that don't affect its overall identity. So the immutability, therefore, becomes a non-issue. It's no longer a weak point. The fact it's immutable is actually a good thing. It's harder to fool another device into the network. Or government records, things like your name and social security number. Theoretically, the relationship between those two is never going to change. So if that's immutable, it's not a problem. And both of those things are things that are going to be read probably only in one or two spots, or the number of spots in which that identity is going to be brokered back and forth for the access management is very small. It's not going to be something widely distributed across, say, 150 websites I visit every day or something like that. But then that website thing brings up another ideal use case for it eventually, is identities that are shared identically in multiple places. So there's an idea that maybe someday you could have your identity be in a block, and you have control over that block, and when you go to websites, they just read your block for your identity information. And this is good because you have control over it, you know where it's going. They call it a portable non-custodial identity because it's non-custodial because the people using it don't hold custody of it. You hold custody of it. It's your block. And it's portable because that block can be plugged in multiple places. Now, of course, this requires significant architectural changes because then everything has to be able to read identities from a block. And the blockchain, if that was an idea that were to work, there's 7 billion people on Earth, two-thirds of which are probably using the internet actively enough to require a block, then you're going to have a very, very large blockchain that there's going to be a lot of computational energy being taken up there anytime something needs to be changed. Changing, of course, goes into drifting identities. The web identity usage, one of the problems with that makes it a non-ideal use is the fact that you can have a drifting identity. My phone number changes a lot. So I'm not going to want to be, if it's a block-based system, every time my phone number changed, they would have to recompute the system, recompute an entirely new block for me, effectively create me an entirely new identity, because the previous one that was made is immutable. It can't go back and edit a record inside of it like that. Also, things that are directly tied to a life state, like college. In 2 years, 4 years, 5 years, 6 years, whatever, when that person graduates college, that they have moved on to a new life stage, at which point that old block is going to have to be destroyed. If you're a college, that might make sense, but if you're looking for a portable non-custodial identity, it doesn't make sense to have that be included in it, so that's not an ideal use case. Same thing with a revocable identity. A company might say, oh yeah, we hire great people, we're going to keep them, we're going to build them each a block. That's probably not true. I mean, you're going to have like a one-third turnover or something like that. Then it means you're going to have to rebuild. Every time somebody turns over, you're going to have to rebuild a new block that doesn't have that person in it. When you hire somebody, you have to rebuild another new block that has that person in it. And because each block is a computation of all the previous blocks, you can see how that eventually gets to be a problem. And then the last thing that's not an ideal use case is a segmented identity, when there's only one part of identity that's needed. In that case, why are you adding the complexity of blockchain unless that one part of identity is extremely, extremely sensitive? So here's my conclusions. I think that the strength of the blockchain, of course, is the immutability, and it's highly secure for a very stable identity. And it's nice for when we are going to have that. I think we will eventually have that distributed non-custodial, user-controlled identity thing going on that I referred to before. I think that will eventually happen. But the weakness, of course, as I've said a number of times, is it's immutable to a fault. All right, it's not designed to be changed. It's not designed to handle drift. And it's still only as strong as the IAM platform it's connected to currently, because there aren't things designed to read straight off a block. There's still going to be something brokering access to your apps and your resources. And of course, the 51% problem chains are weak when they start out. When they're small, unless you're hopping on the back of somebody else's established chain, which if you're sensitive enough that you're thinking to yourself you need to have blockchain identity in the first place, you're probably not going to do. You're starting out very vulnerable. Now, I do want to throw some opportunities in here for managed service providers and managed security service providers. That is this. If you're looking to provide security services to somebody, the first thing you always have to start off is to secure their current situation. So take a current solution that's out there and implement it in a secure way to keep your customer secure. Don't say, oh, we're just going to hold off until the blockchain gets here, because goodness knows when that's actually going to be a viable solution. Technology increases it, punctuated equilibrium pace. Make sure that their current solution is secured and best practices are implemented as securely as you can. And then as blockchain matures, you can be a trusted advisor for them as they say, maybe this is a space I want to move into. So here are the contacts. Me as the presenter, of course, if you watch my videos, my email doesn't change, no drift there. Same thing with cybersecurity line card, securitylinecard.com. Any questions, cybersecurity@ingramicro.com. And don't forget to realize the promise of technology. Have a good day.